of you. Let's see design of buck converter. Okay, it's also called as a step down converter. Okay, so we'll design. So as I told you that I have taken one example from Power Electronics by Ned Mohan. Okay, so this is what the book is there, and on the book page number 109, if you see that there are solved problems, unsolved problems. Okay, for step up and step down converter. And in that problem, just I couldn't find any design problem. Okay, but yes, of course I need some reference, so I have taken this book. Okay, so in that book you can see the example number second. Okay, so page number 109 there, and example number 2 you can see that. So example number 2. So in the example number 2, it has been shown that what is the output voltage switching frequency, and then L and C they have given. Okay, so for this particular problem, what we can take is we will design L, we will design what is the value of C. Okay, we will consider this output voltage is 5 volts, switching frequency is 20 kilohertz, and then this VD, or you can say source voltage, is 12.6. Okay, and their resistance they have not given, so we'll consider arbitrary resistance. So design of buck converter, we have output, that is V0 is equals to 5 volt. Okay, and then VD, or we can say VS, okay, source voltage, that is 12.6 volt, and switching frequency FS is 20 kilohertz, right? And then R we will take it as a 10 ohm. Okay, this is your load resistance. So this reference we have taken. Okay, this reference problem we have taken, and we will start designing a buck converter or step down converter. Okay, so let us start with this. So first we will find out what is the duty ratio. So what is the duty ratio? Duty ratio is it's a mathematical equation, so it's defined as a D. Okay, so duty ratio D is nothing but V output voltage divided by source voltage, Vs. If you see, we have V is equals to 5 volt, and this is 12.6 volt. Okay, 12.6. So we'll have this 5 divided by 12.6, and which comes out to be 0.3968. 0.3968. Okay, so this is what the value of duty ratio. Okay, and then percentage duty ratio. Why this is required? In order to generate that PWM pulse. Okay, so this duty ratio, percentage duty ratio, is nothing but percentage of this. That is your 39.68 percentage in terms of percentage. Okay, is that fine? Next, we will find out for the PWM pulse. Okay, so PWM pulse, we know that we have already done these calculations in MATLAB. Okay, so for 100% duty ratio of duty cycle is there. Okay, so we'll have a 360 degree, and for then we have duty. Okay, duty cycle. Okay, that is duty ratio, that is 39.68%. Okay, so for 39.68%, how much it is, that we have already calculated, and that comes out to be, we can multiply, this cross multiplication is there. So 360 multiplied by 39.68 divided by 100, and that will comes out to be the so that PWM pulse generation from 0 to which degree. Okay, so likewise. We'll calculate this. So it's like a 360, then multiplied by 39.68, and then this is divided by 100. So it's like 142.85. 142.85. Okay. 142.85. So let me draw this diagram. So what we need a supply voltage, okay, Vs, and then one switch. Okay, in this case we will use MOSFET. Okay, so this switch is connected to, okay, so PWM will give to the switch, okay, the gate pulse, and then we have a diode across here, and then we have inductor, capacitor. Okay, we have inductor and then capacitor, and then load resistance. Okay, so up till now we could find out this. Okay, uh, duty ratio. Now we need to calculate the value of, okay, one L, and one, then we have this capacitor value. Okay, uh, inductance value. We'll calculate inductance value. So inductance value, we have a formula. Okay, L minimum we have, that is 1 minus d into the resistance value, whole divided by 2 times your switching frequency. So we have d value, that is 0.3968 multiplied by 10 divided by 2 times 25, or what is this, 20, it's a 20 kilohertz. Okay, that will be your 20 kilohertz frequency, and we'll get L minimum. You can calculate this if you have calculator. Okay, so likewise I will calculate this as 1 minus 0.3968 multiplied by 10. Okay, then I don't know how to shift this. Yes, we need one more, and then here we will divide it by 40 kilohertz. Okay, 40 kilohertz. Something was error. Let's go to, it's like L minimum 1 minus t, minus 0.3968 multiplied by R. What we can do is we can take it, there was an error. Okay, so what is that error? I don't know. Yes, now it's fine. Yes, so I think, and then it is divided by, it's 40 kilohertz. So it's like 1.50. 1.508 into 10 to the power minus 4. 1.508 into 10 to the power minus 4. This is your L minimum, or you can say inductor value. Okay, and it is in terms of Henry, L minimum. So if you want that continuous current conduction mode, okay, for continuous current conduction mode, your L should be 25% larger. 25% larger. Okay, so we need to find out 25% of this, and then we can add your L, or you can say L final, or inductor final, inductance value, that is L. Okay, I will make it as L, and then 25% of this. Okay, So if you make 25% of this and then you can add with this, okay, so it will like, okay, 25% of 1.508 into 10 to the power minus 4. Okay, its value 25% I have already calculated here. Okay, so it's like 3.7698. 7698 into 10 to the power minus 5. Okay, and then this 25%, okay, I will make it as L25 is equals to, so final L, the complete L will be nothing but addition of this to L minimum plus L25. Okay, so if you add these two values, so we'll get a value of L. Okay, so it will be like 1.508 into 10 to the power minus 4 plus 3.7698 10 to the power minus 5. So it will be like 1.1.88498. 1.8849, okay, 10 to the power of 10 to the power minus 4. 10 to the power minus 4. Okay, so this is the value of your L now. In this case, now we need to find out the value of capacitor. So capacitor value, the formula is 1 minus T whole divided by 8 into L, and then ripple voltage is there. Okay, so it will be like somewhere you can see that change in output voltage divided by complete output voltage. Okay, so this is what your ripple, and then it is multiplied with your f square, fs square. Okay, so this term, okay, this term can be of, you can say it's very less than this is what ripple. Okay, so ripple can be it's less than 2%, so we can consider this value as a 2% in this case. So I will put the values 1 minus d value, okay, that is 0.3968 divided by 8 times this inductor value. Okay, that is 1.8849 into 10 to the power minus 4. Okay, into, we can make it as 2%, so I will keep the value of as 0.02 here. Okay, and then we have fs square. Okay, that fs square means we have a frequency that is 20, yes, 20 kilohertz. 20 kilohertz, and it's a square. Okay, so if you calculate with the help of calculator, okay, you'll get a value of C. Okay, so what is the value? I have this value directly. Okay, it's like 5 into 10 to the power 5 into 10 to the power minus 5. You can calculate this. Okay, you can calculate this with the help of calculator. Okay, so it will be like difficult for me to press the key on the calculator. Okay, because it's lengthy calculations is that. So so the value, which is nothing but C, is nothing but 5 into 10 to the power minus 5. Okay, so I will simulate now. If you understood this much is calculation, design calculation. So we got the value of L. If you see this, we got the value of L, we got the value of C. Okay, R we already know. Okay, the Vs, that is source voltage, that is 12.6 volt is there. Resistance value, we have taken it as a 10. Okay, and we have calculated the value of PWM, that is 142.85. Okay, so this is the three values. Okay, we'll put this all three values in the circuit, and then we will see, or we'll analyze whether we will get an exactly output voltage that is 5 volt. Okay, so we are designing buck converter or step down converter. Okay, I will move to this PSIM. Okay, so make a new file, and then yes, now I need a Vs. Okay, so here you can see that the icon is there. Okay, so this is what your supply voltage. I will make it large. It's too much large. Okay, this is my Vs. Okay. And then as per this diagram, I need one switch, so I will consider MOSFET here. So there is a MOSFET here. Okay, and I can rotate this MOSFET. Then we need an inductor and diode. Okay, so inductor, I will take, this is inductor, and then resistance, and then one diode is required, and we can connect these connections first. Okay, yes. Now in order to, yes, this is what MOSFET. Okay, switch 12 volt, we need a PWM pulse. And one capacitor is required. Okay, now if you double click, we'll change the values of this. Okay, this is what is your complete circuit is then. Okay, and yes, we'll change the value. Okay, this is your Vs. So for Vs, we have the value is 12.6. I will make change 12.6 to here. And then for PWM, as we have discussed here, so PWM, see, it's like 142.85. So gate pulse we will give accordingly. So double click on this, you can see here. So here we want that value. Okay, so what is that value? And also switching frequency. Okay. So 142.85, and then we have switching frequency that is 20 kilohertz. Okay. So 142.85, 0 to 142.85. We'll keep this output displayed. And this is your switch. This is your inductor value. Okay, and what is its value? Inductor value. So 1.8849 into 10 to the power minus 4, we have this value. We'll keep this value. That is your 1.8849 into 10 to the power. So e to the power, it's minus 4. Yes, it's minus 4. And then we have this resistance value, we have taken it as a 10, so it's by default 10 value is there. And then capacitance value, so capacitance is 5 into 10 to the power minus 5. Okay, so it's like 1 micro. We can keep it 1 micro also, but e to the power. Okay, when you increase the value of capacitance, so you will get a less ripple. Okay, so I will put this right now, e to the power minus 5, 5 into it, whatever we have got that value. Okay. A resistance value I will keep displaying. And then we will run this simulation. Now this completes. So this is what the run icon. Okay. So we'll require a simulate control. You can take it. Okay, it's already simulation. Okay. We'll take one simulation control, and yes, of course we can make it as okay. Then time step, it is like 9.92. Okay, you can change or you can keep it like this. Okay, we'll make it as 1 in the time step, and then we will rerun this simulation. So that's why it was asking for the time step in the earlier case. We have not kept V in and V out. Okay, that also we have forgotten. We'll keep it here. This is for calculation of input voltage and output voltage. You can measure other parameters also, that is current also, output current. Okay, but I will not see this. Okay, I will not measure it right now because so this is my V in, this is my V out, output voltage. Let's see this, and now it's already running this simulation. Okay, so better we should wait for this. It's not responding, it's coming. We have not saved the file also. Okay. New. So initially it will take time. Okay, not run it. Just wait. So if you have any queries, you can ask me before this. See, these calculations you might have studied in your power electronics subject. Okay. So how to calculate in the designing part. Okay. So sir maybe taught about this, about the current conduction mode or something like that. And then how to calculate this value of capacitor and the resistance. Sorry. Even if we have uh, we can calculate ripple also. Okay. Likewise, in this particular problem, they are asking you to calculate this peak to peak. Okay, change in the output voltage. Okay, so that is also possible. Okay, so in order to design, so you can refer those notes which are shared by Rausa. Okay. Dipali, Sunny, तीन लोग हैं सिर्फ, only 3 students are there. Okay. Okay, yes. We have already, as we have not added this, you can say ground terminal to this. Okay, so there's nothing is there. Meanwhile, it will run. We'll go for this another, okay, theory of another converter, boost converter, we'll say, step down, a step up converter. Okay. Okay. I'll rerun this. Inductor. It's hanged. Okay, then we need. Okay, so it is coming out. V in, and then I will add V out. Okay, so is it visible? Now you can see this. Okay, so I will show you the measure block. Okay, so in the measurement you can see, of course, you can see this much. It's not responding. Okay. Yes, 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 it's coming. So this is what your output waveform. Okay, so I will change this V out, V in color to this. Okay, blue color, and its thickness I will make it as 4, and then this is what your V out. I will make this as a green color and let it be like 2. So you can see that this is your input voltage, okay, and you can see this in the measurement, okay. So input voltage is around here. You can see that 1.26 into e to the power plus 10. That is your 12.6 is your input voltage, okay. You can see here it's around 12.6, okay, which we have thought of design, okay. And then V out voltage, that is your 5 voltage, okay. If you zoom out, okay, if you zoom this waveform, you can see that this is around 5 voltage. You can see here it is 4.977. Okay, so it's around 5 voltage. Okay, so likewise, if you want to, you can say, okay, yes, if you want to see that where it is, okay, here it is. Yes. If you change this, you can say capacitor value, your curve will be like more filter out. Okay, again, this is what the standard value which we have calculated. Okay, so if you zoom out this output waveform, okay, you can see it here. Some ripples are there. Okay, these are the ripples. Okay, these are the ripples. If you want to if you want to minimize the ripples, if you want a straight line, okay, then you can change the value of capacitance. Okay, you can increase the value of capacitance, and then maybe the ripples will be less. Okay, but as far as if we have considered here 2% of the ripple, okay, maybe you can consider it very less often. Okay, in some of the books you can find it's below 4% also. Okay, this ripple, or 5% also. So that is what all about uh, your buck converter. Okay, step up converter. I will again go back to this. Okay, now it's, yes. So at input we have, this is what, 12.6 voltage, and at the output we got a 5 volt. Okay, so this is what the step down DC-DC converter. Okay, step down DC-DC converter. So any doubts here? It's 138 already, 137. So I think we will stop. I will, yesterday I asked you, yesterday I thought to give you an recording videos, but it was not possible for me. So yes, so I will stop it here, and then we can see this boost converter. I will record this video of boost converter, and then I will share to you. Okay, and if you have patience to stay here for 20 to 30 minutes, okay, it will take less time. Okay, we will design part is there, and then we will simulate that particular part. So if you have time, you can tell me whether I should continue or I should give a recorded video for this boost converter. So the choice is yours.
So please continue.
Shall I continue? Okay.
Yes, sir.
Okay. I will close this and then we'll move on it. So this is what the diagram for your boost converter. I will join this, and of course, yes, I forgot to add here one capacitor. Okay. And add to here and remove this portion. So this is what your resistance, capacitance, inductance. This is what your diode. Okay, and this is what your VS. Okay, so again, I'm going back to this book. Whether the screen is visible?
Yes, it's visible.
So it's like a step-up converter. Again, you can refer this problem. Okay, 7.8 problem. So they have given some values. Okay, so I will use that input voltage, output values, output voltage value in our problem. Okay, so it's like if you have this Vs, okay, or Vd, it's mentioned Vd is equal to 12 volt, Vo, our output voltage is 24 volt. Okay, we'll consider this value, and then we'll take a switching frequency that is again it's a 20 kilohertz. Okay, so this we will take. So design of boost converter. So we have this output voltage is 24 volt, supply voltage is 12 volt. Okay, and then switching frequency is 20 kilohertz, and you have this resistance value that is by default 10 value we'll consider here. Again, we'll need to calculate what is the duty ratio for this. Duty ratio. And now the formula is different, 1 minus Vs by Vo. 1 minus Vs by Vo. We can calculate this. Okay, it's a small calculations. So Vs is, yes, Vs is your 12 volt. Okay, so 1 minus 12 by 24. So it's like 0.5. Okay, so 1 by 2. It's 0.5 value. This value is 0.5. 1 minus 0.5, 0.5 value. Okay, so this is what your duty ratio. Again, we need to calculate the percentage of duty ratio. Okay, so percentage of duty ratio. Okay, so it's like in D percentage of duty ratio, it's like a 50%. 50% D value is. Again, we need to calculate PWM pulse output. Okay, what should be the PWM pulse output? So as we have already made these calculations for 100 degree, okay, 100%, we need 360 degree. So how much degree is for the duty cycle? 50%. Okay, so it will be calculated like 180 degree. Okay, so 50% means 180 degree, 100% means 360, so 50% means 180 degree. So PWM pulse we need to give 180 degree. Okay, this is what the calculations is. And then we need to calculate the value of inductance, which is minimum inductance. Okay, which is minimum inductance? The formula is 1D into 1 minus D square into the load resistance divided by 2 times Fs. Okay, we'll put the value, what is D, that is 0.5. 1 minus 0.5 square into R value is 10. 2 times your switching frequency is 20 kilohertz. 20 kilohertz. Okay, we'll try to calculate this. It's like 0.5, 0.5, in bracket, it's 1 minus 0.5, then bracket square, okay, then multiplied by 10, and then I need whole divided by 40 kilohertz, okay, 40 kilohertz, it's not there, kilohertz, okay, and 40 e to the power is not there for it will be like 3.125, yes. So 3.125 10 to the power minus 5. So that will be 3.125 into 10 to the power minus 5. This is what your L minimum value, and we need to calculate 25% of this in order to make it as continuous current induction mode. Just wait. So L25 we can calculate based upon this. How do we calculate? We can multiply L minimum to 25 and then divide by 100, which will give you that particular 25% value. So I will multiply this value. Okay, just wait. It is like hanging again. Okay, I'm having the direct value. Okay, I will instead of calculator. Okay, it's like hanging calculations. So L25 value. Okay, so L25 values that I'm right now having, that is 7.8125 into 10 to the power minus 6. Now we need to calculate the value of inductance. So it is like L minimum plus 25L, and its value is 3.9063 10 to the power minus 5. Okay, so this is what your final L value, and yes, of course we can consider calculation of capacitor value. So its formula is dt into r multiplied by your ripple into your switching frequency. So this part we can consider it as 2%, okay, 0.2%. So what is the d value? D value is 0.5 divided by r value is 10. This is 0.02 multiplied by your switching frequency is 20 kilohertz. Okay, 20 kilohertz. So we can calculate the value of C now. We can calculate the value of C now. Okay, 0.5 value, I don't know, okay, divided by n multiplied by 0.02 multiplied by 20 kilohertz. 20 kilo. It will be like the capacitance value is 1.25 into 10 to the power minus 4. Okay. So this value can consider 10 to the power minus 4. So we got all this value. Okay. Okay. So we'll keep these values. Okay. So we have this Vs is equals to 12 volt. Okay. And then we have this value of L. So it is 3.9063 into 10 to the power minus 5. And okay, 10 to the power, okay, E or 10. Okay, then we have this value of capacitance. Capacitance value is 1.25 10 to the power or e to the power minus 4. Okay, and then r value is 10. Okay, so and then we have this PWM is connected to this switch. We will simulate this now. We need a voltage source. This is what the voltage source we have. Voltage source, and then we need a MOSFET. Then inductor we require. Then diode. And capacitor. And then resistor. Reload this capacitor, resistor, and then we can make connection. Inductor goes to this goes to this to capacitor, capacitor goes to resistor. Yes, we have finished. Okay, we'll give ground, okay, which we have already many times. I forgot to add ground to this. Then we'll calculate or we'll measure input voltage and output voltage. Yes. Now give the values. Okay, so we have for this step up converter, Vs is 12. Okay, let me go to this. Yes, Vs is 12. Then inductance value of inductance 3.969063 into 10 to the power minus 5. 3.9063 power minus 5. We will show this value and we'll make it as L. This is also displayed. And yes, diode is there. Okay. This is what the capacitance. The capacitance value is 1.25 e to the power minus 4. 1.25 minus 4. Okay. Okay. Then value of resistance is by default 10 value. Okay. This is RL. This is your V in, V out. So now we have completed. Okay, we need one PWM pulse to be given, and it's by default. Can double click. Okay. So it's by default that points at 0.0 to 180 degree. Okay. So this is what the gate pulse is. Switching frequency, it is 20 kilohertz. Okay. So 20,000. Yeah, finish this one. We can name this as MOSFET and be displayed. This is your diode and be displayed. We'll give a name. Okay, we'll give a name to this. How to give name? Here is A, which boost converter step up in bracket. Oh, it's not this one. One more, that simulate control block we need to add. Okay. My complete computer is hanged, I think. Okay. I've given the name to this and will simulate. Okay, yes, simulate control block. I'm adding to this. So let us make it as for 5 seconds to run, and then you can run this. So for V in, I will add, then V out, I will add, and then maximize this window. And yes, of course, you can measure auto measure block. Okay, so you can see that measurement block I have added. Okay, so whenever you move this cursor, you'll find the value changing. Okay, you can see this value can change over here. Okay, so what is V in, what is V out, that you can see. So for at any side, even it can be seen, it like you can say it's a straight line. So output is 24, input is 12 volt. So this is your boost converter, step up converter. This is what we are looking for. Okay, so output is 12 volt and input is sorry, output is 24 volt, input is 12 volt. Yes, you can see that output is 24 volt and input is 12 volt. And at all these pulses, okay, it's like say again here also, this is what the ripple you can see. Okay, so this kind of ripples are there. Okay, you can minimize this ripple. So ripples is like from 23.75 to 24. Okay, so you can minimize the ripple by adding capacitor value or any other filters are also there. So for that purpose, you need to study the filter designing part. Okay, so just for the basic boost converter, it is like this. Okay, so I hope you understand this. Now I will stop. I will stop it for today. Okay. Let me stop recording first. Okay, is there any question? So we have covered buck converter, boost converter. Okay,